Hi everyone, I'm Billy. We are Team DevOps. Our development team members are Benny, Devon, Jay, Ryan, Sam, Chantal, and me. Our dial are Olivia and Frank. The business analyst is Christine, and the tutor is Son. Today we are going to demonstrate our project, Blue Period CRM. In this demonstration, we have 4 parts. The first part is an introduction. In this part, we'll talk about the purpose of our application and also talk about our team, the project management, and the tactics of our application. In the second part, we'll pass to our dialogues to introduce the architecture of our application and the related technology. In the next part, we'll talk about our application functionalities and demonstrate our application to you. In the last part, we'll talk about our team reflection and future plan. The Blue Period CRM is a business-to-customer type CRM system, which is the most common type of CRM. The main purpose of our team is to develop a system that can help a company to manage their customer relationship, product information, also manage order status and issue invoices to customer as well. The ideal CRM system can help the company to find potential customers, analyze the sales of products, and establish a better sales strategy. We are a 10-person team that includes 7 developers, 2 dial, and 1 business analyst. We are an agile team, and we hold a standard meeting every day from Monday to Sunday. We developed this project in 6 2-week sprints in total, and we have a sprint retrospective at half of the sprint and when finished is sprint. These are the tactics we use in our project. To minimize the cost of debugging, we decided to use TypeScript on the front end and backend development. In the front end, we use React Hook and the Redux for the state management, and use the Sass and CSS module and MUI to complete the interface. In the backend, we use Express via Look.js to implement RESTful API and also use Mongoose to connect the MongoDB, and use the third-party API, which is SendGrid, to implement the specific function and also involve microservices such as Lambda. Unfortunately, even though we understand the importance of unit tests in the development process, we cannot implement them due to the time constraints, but we'll implement the corresponding tests in the subsequent maintenance process. And this is our database structure in our application. We have included 5 connections in total, which are user, customer, product, order, and invoice. And now I will pass to Olivia to introduce our project structure.
Hi everyone, I'm Olivia. I will give a brief introduction to the structure of Blue Period CRM and the tools we use for continuous integration and delivery. Blue Period used a single region 3-tier architecture organized into presentation, logic, and data tier. The presentation tier is served by AWS S3 and CloudFront. We use Route 53 for domain names and route end users to the app. We use S3 to serve the static content and CloudFront for edge location caching, which decreases the latency to deliver content to our customer. It worked well with the AWS Certificate Manager to provide an encrypted connections for our app. The application is implemented as ECS Fargate tasks that span across 2 availability zones, deployed in a private subnet to ensure security. The private subnets do not have direct access to the internet. Therefore, a NAT gateway is attached to solve this problem, so that the tasks are able to request ECR images or send logs to CloudWatch. In order to allow traffic from public to reach our container, an internet-facing application load balancer was deployed. Users can access the application load balancer. ECS triggers the load balancer to forward the request traffic to the container task. Each Fargate task is attached to an elastic network interface. The IP of the network interface is added to the load balancer's configuration. When the task is being shut down by auto-scaling activity, the network traffic is safely drained from the task before removal from the load balancer. The configuration we use here allows our application container to be safely isolated from the rest of the internet. They are capable of initiating communication with external resources via net gateway and still be able to receive traffic from the public via the application load balancer. For a PDF generation feature, we deployed using Lambda function and API gateway. The Lambda functions are behind API gateway and accessible using the URL path. The usage of Lambda function benefits from the serverless architecture, reduce server latency from heavy computational costs during PDF generation. The application load balancer and Fargate task also send logs to CloudWatch, which will be imported to Grafana for monitoring and alerting. The data tier was implemented using MongoDB Atlas. We use separate database for UAT and production. The connection string was added to the secret manager for a secure connection. Next, I will talk about the tools we use for continuous delivery. The Bitbucket pipeline was used for front-end CI/CD. The pipeline is triggered on code merge on to the main branch, where the Bitbucket pipeline will look for a YAML file and execute the pipeline steps. The AWS credential used while pipeline execution was stored as secure repository variables. After a successful build, the deployment artifact will be copied to the S3 bucket. We use AWS code pipelines for backend CI/CD. It provides continuous delivery services to implement the entire deployment workflow. After building a connections to the Bitbucket repository, AWS code pipeline will detect merge actions on the selected branch and fetch the build spec file in the repository. Next, the code build stage will execute the build spec, dockerize the backend, push the image to ECR, and update the task definition. The final step is for code deploy to use the updated task definition to initialize new services using the latest Docker image. We also enable CloudWatch logs for code build so that we are able to monitor failed builds and get notification if anything goes wrong. We use Amazon Managed Grafana to monitor the infrastructure and log analytics. The panel includes in the dashboard are UAT, production error rates, the CPU utilization status of the production backend, and the failed build count for AWS code build. We also set email alerts for certain events like failed builds or high error rate. That's me at the end of my talk, so I will now hand it over to Sam. He will go through the system and show some basic feature.
Thank you, Olivia. Hi, everyone. My name is Sam. Please allow me to guide you through the user experience of Blue Period CRM. The hierarchy of our website is shown here. After login, user will be directed to the dashboard page and grant access to all pages. We have 4 data models for business usage: customer, product, order, and invoice. Customer and product have corresponding create, view, edit page, but order has one edit page and invoice has detail page only. In terms of functionality, the first basic function will be user authentication. We provide common authentication flows such as login, registration, and forget password. Once user register or forget the password, an email verification will be sent to the corresponding email. After login, user enter the dashboard page. Some data analysis module is shown here. And we have a site navigation to navigate to other pages. The main page contains a table for displaying all related data instances. It has power features such as searching, quick filtering, sorting, which will be shown in the demo later. The create page and the customer and product have create page, which provide user ability to manually create data instance here. The detail page is showing the full detail of our data instance. We can also edit existing data instance easily in the corresponding edit page. Order is the center part of our data model. It consists and connects important information from all other three business models. The user have ability to approve or reject a pending order. When user reject this order, the order status become rejected and cannot be modified further. But if order is approved, the user's order count and total spend is increased. Corresponding product quantity will be decreased. And finally, an invoice is generated automatically after the successful approval. Our invoice detail page has gathered all crucial information to compose an invoice. Users have the ability to preview invoice version of PDF version of invoice or send the invoice to our customer. But unfortunately, the sending service is still under development stages. Finally, let us move our steps to the demonstration part. Welcome to our login page. I'm going to log in using my account here. Or before that, I can show you the registration, the forget password link here. And let's log in. This is our dashboard page. We can see a few data analysis module here. An alternative way of modifying user information will be clicking the profile. Basic user information is presenting here. I can modify my name if I want. Anything I like here. And also I can change my password by passing the email system here. Here is our main pages. Yes, customer, product, order, and invoices. We provide full-featured data query method here, such as search, the filter, the sorting by field. And for product and order main page, we also have built-in quick filter options for the frequently used fields, such as status of the product and status of the order. And of course, we can easily use those query options together. Now let us focus on the particular data instance SAM. Sam has 3 orders and 39,000 spent in our system. He placed some order in our system and we like to approve. Let us approve the first order. Sam, the order has been approved. Back to Sam. The order counts has increased and the spend increased. Now let's move to our limited product NVIDIA RTX 3090. It has quantity of 8 and Sam like to buy all of them by placing order of 8. We can see the limited product is gone because the quantity becomes 0 and the status become out of stock. Finally, Sam would like to buy more of 3090, but we don't have any more 3090 in system. Therefore, the order cannot be approved and a warning is generated. In this case, the user can easily reject this order to inform the customer. Finally, we have our invoice. We can access invoice from here or the exchange here. Furthermore, we can access invoice from the particular customer detail pages. The invoice have all the information we need, but for the functionality part, we just click the preview page and wait for the Lambda function to be returned. A clear invoice PDF is shown in the new tab. User can manipulate this PDF, can print it or download it. And back to the demonstration.
Thank you, Sam. Now I'm going to talk about the reflection of our team on this project. When the team compared the final product and the proposal expectation in the last sprint with respective, find that the application was more completed than what we expected. Most of the main features has been completed. For example, we finished the login feature, the basics API function on customer, product, and order pages, and some additional features has also been successfully implemented, such as email service, invoice PDF generation, and also implement Lambda function. But some features are not available yet, such as data visualization and data analysis in the dashboard. For the innovative features, our team make a reflection. We understand that the teamwork is more important than individual ability. The team members can help each other and provide suggestions to help solve problems and improve together. And we also need to reflect on time management. For example, we spend too much time on the research at the first sprint, resulting in relatively late progress in the initial stage. And at the same time, as the developers, our basic capabilities has also been improved because of this project. For example, the ability to find solutions, the ability to seek help from others, and we need to keep constantly curious about the new knowledge. Of course, we also create a deeper understanding of thinking in React. As a result, although we successfully developed this application, we also find out many possibilities and extensibility of this project, such as uploading image for the product to help user have a better experience in managing products, a calendar that can host the business events, and finding need management to promote products, and also integrate data visualization on the dashboard to help businesses to build their strategies. It is also possible to extend our email service to send invoices to customer after the order has been completed, and log in with different roles to authorize different operations on the application. It is hoped that in future maintenance, the new functions can be continuously updated to improve this application. This is the end of our demonstration. Thank you for listening. Any questions?